The topic of our presentation is the Clarke 3 laws. It is for an MIS 447A class, and it is presented by Team Zeppelin, which consists of Adnan Palanpurwala, Abdul Aziz Jawani, and Naguib Chaudhry. Arthur C. Clarke was a prolific author of novels, essays, and stories, one of which served as a basis for the movie A Space Odyssey, and has made more than one mind-boggling forecast. He is often credited with having developed the idea of using satellites with geostationary orbits as a telecommunications relay system based on a paper he wrote in 1945. Clarke's laws are a series of three rules attributed to science fiction legend Arthur C. Clarke, intended to help define ways to consider claims about the future of scientific developments. These laws do not contain much in the way of predictive power, so scientists rarely having any reason to explicitly include them in their scientific work. Despite this, the sentiments that they express generally resonate with scientists, which is understandable since Clarke held degrees in physics and mathematics, so he was a scientific way of thinking himself. Clarke analyzed that competent men had laid down the law about what is technically possible or impossible into two classes: failure of nerve and failure of imagination. Failure of nerve is a notion that is common and occurs when, even given all the relevant facts, a person cannot see that they point to an inevitable conclusion. Some of the failures are so ludicrous as to be almost unbelievable, such as the invention of the light bulb by Thomas Edison, which was put down by all experts as unworthy of attention of practical or scientific men. Another famous and perhaps the most instructive failures of nerve occurred in the field of air or astronautics. At the beginning of the 20th century, scientists were almost unanimous in declaring that heavier than air flights were impossible, and that anybody who attempted to build airplanes was a fool. It was not until the news of the Wright brothers' success, who mounted a gasoline engine on wings to build the first airplane, that people started to think of flying machines as a possibility, but were uncertain that it didn't have any practical importance, as they won't be able to carry the extra weight of the passengers. Nowadays, airplanes are one of the most important means of transportation, not just for passengers but also for business uses such as UPS and FedEx, in shipping goods from one place to another. Failure of imagination arises when all the available facts are appreciated and marshaled correctly, but when really the vital facts are still undiscovered, the possibility of their existence is not admitted. Philosopher Auguste Comte attempted to define the limits within which scientific knowledge must lie. He decided that stars could never be more than celestial reference points. He believed that definite knowledge could be obtained from planets, and even that would be limited to geometry and dynamics. Comte would have disagreed that a science such as astrophysics could exist. Within half a century of his death, almost all of astronomy was astrophysics, and very few astronomers had interest in the planets. His assertion was refuted by the invention of the spectroscope. Comte cannot be blamed for not imagining the spectroscope, but he does provide a warning that should always be borne in mind. Even things that are undoubtedly impossible may prove to be easy as a result of scientific breakthroughs. Failure of imagination was persisted by Lord Rutherford also, who laid bare the internal structure of an atom. He made fun of those who predicted that one day we would be able to harness energy locked in matter. In 1937, 5 years after his death, the first chain reaction took place in Chicago. What Rutherford had failed to take into account was that a nuclear reaction might be discovered that would release more energy than required to start it. The example of Lord Rutherford demonstrates that it is not the man who knows most about a subject and is acknowledged master of his field who can give the most reliable pointers to its future. Too great a burden of knowledge can clog the wheels of imagination, and this observation can be embodied into Clarke's first law, which Clarke in 1962 included in his essay Hazards of Prophecy. The first law states, when a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he is very probably wrong. In physics, mathematics, and astronautics, the word elderly means over 30. Every researcher right out of college knows that scientists over 50 are good for nothing but board meetings and should be kept out of the laboratory because of that age, one's thought process is less inclined in thinking towards major revolutions. The pioneers of human civilization have never hesitated to push the limits of the realm of possibility. Possibilities defined by tradition and conventional belief. Institutionalized possibilities beyond which had been applied lie the impossible and improbable. Impossible is a word to be found only in the Dictionary of Fools, uttered Napoleon Bonaparte, who was starting as a second-maire lieutenant in the French artillery. Once commanded a territory that stretched from Portugal to Italy and north to the river Elbe. Arthur C. Clarke ascertains the notion when he boldly states, "The only way of describing limits of the possible is to venture a little way past into the impossible," as his second triad of the laws. He maintains that the only way to certify of what's possible in a context is to expand outside of its known boundaries. The case of Charles Babbage and his marvelous automated computing machines comes up as a prime example in his essay. Babbage pushed the limits of the primitive technology of the post-industrialized revolution, when at the time most of the calculations were performed by human calculators in numeric tables and highly error-prone outcomes. He sought to automate the process by creating a difference engine based on Newton's method of divided differences. It was that founded the ground-level framework for modern computers, a concept now ubiquitous, would fall between the dominion of absurdness and the impossibility in the early 19th century. But Babbage didn't stop there. In the later half of the century, he began an even more ambitious project of analytical engine, which in theory would be capable of making decisions based on concurrent situation and receive input via punch cards. Alas, here is where the genius finally succumbed to the impossible. Neither the mechanical technology of the time was advanced enough to materialize his complicated predictive algorithms, neither did the British government manage to comprehend the significance of its potential. It took about another 50 years when the development of necessary mechanical and electrical intricacies essential of his machine took a head start. When Clarke acknowledged the second law in 1973, he decided that there should be a third law to help round things up. Clarke's third law states, "Any sufficiently advanced technology is indistinguishable from magic." This is by far the most popular of the three laws. It is invoked frequently in popular culture, and it is often just referred to as the Clarke's law. This law can be best explained with a simple example. If you were to go up to a scientist in the late 19th century and tell him, "Here are two pieces of uranium-235. If you hold them apart, nothing will happen. But if you bring them together, you will liberate as much energy as burning 10,000 tons of coal." The obvious answer from the scientist would be, "This is impossible under science, but might be possible via magic." The other answer that you might expect from a scientist in that time would be that energy cannot be created out of nowhere. The best thing these scientists have seen yet in terms of chemical reactions is combustion, so this might be hard to digest for them. One of the other simple modern examples would be Apple's iPhone, which has shown consumers far better ways to interact with technology than simply through buttons. While the iPhone's groundbreaking touchscreen and touch-friendly user interface may be the most obvious and impactful example of this stance, ushering in an entirely new wave of cell phone innovation, advances such as iPod scroll wheel or the more recent gesture-sensing touchpads found in the newer Mac laptops are also great examples of how Apple has advanced touch interaction. Who would have imagined this kind of stuff 20 years ago? Along with the likes of Isaac Asimov and H. G. Wells, Arthur C. Clarke stands a giant in the genre of science fiction, an honorary distinction owed largely in part to his prolific vision. The three laws in our discussion are, at their core, three simple observations, rather close to hypotheses, perhaps deriving from historical contexts that share the same set of recurring themes. Revolutionaries, visionaries across different times and spaces, could find their fates outlined by his first observation that the old guards of Rome hardly bought themselves accepting a nouveau idea that changed the current tides, and especially the one that challenges their own constituted values. Galileo had spent his later years in house arrest because of his affirmation of Copernicus' heliocentric model of the solar system, which conflicted with the Catholic Church's Earth-centric one. Giordano Bruno was burned at stake when he went a step further by applying the idea into a concept of multiple solar systems. Clarke's second law deals with the problem of setting boundaries to possibilities. What's possible in common sense can only be verified in attempts to overcome it. We can see the idea resonate in mankind's long endeavors of flight, a concept which experimentation predates the birth of Christ. For long, man tried emulating the flight of birds in forms of attached wings, glides, or balloons at best. The suggestion that flight could take off successfully with something heavier than air and much stronger, sturdier structure that could in turn help accommodate and aid to generate sufficient energy was worthy of mere lampoon and ridicule till the successful series of flights by the Wright brothers. Just as their achievement opened up new possibilities for the flight of massive and powerful frames, it also shaped boundaries for man's age-long fascination with objects lighter than air. Ignorance and prejudice have been the two notorious drawbacks in almost every field in human knowledge. As a knot, Clarke declares in his third hypothesis, any sufficiently advanced technology is indistinguishable from magic. Indeed, during Inquisition, numerous scientists' experimentation had been suspected to be artifacts of witchcraft. A modern commodity like a smartphone would appear as magical to a common man a century ago. Who would have failed to grasp the mechanisms of its inner workings, or even the concept that materialized them? To many, a native population of Africa, Asia, and America, the simple appliances like telescopes, spectacles, and firearms seem as the wizardry of European colonists and explorers. Even today, in various remote areas, the witch doctors demonstrate their mystical abilities to a populace unaware of the laws of basic chemistry. Besides the depiction of futuristic gizmos and technological surprises, the genre of science fiction tackles with basic human conditions, the biological gas, raw instincts, hopes, ambitions, and follies, everything that makes a human and shapes its characteristics. In fact, judging what humans have done and tended to do in their customary environments, science fiction authors like Clarke envision what they will or are capable of doing in the future. Thus, they investigate behavioral patterns that have been repeatedly manifested since the dawn of human civilization. His three statements in context are observations indicative of such patterns and their coherent reaffirmation in situations dispersed over space and time is what qualifies them as near laws of fundamental human nature. This concludes our presentation. We are Team Zeppelin, consisting of Adnan Palanpurwala, Abdulaziz Jawani, and Naguib Chaudhry. Thank you so much for watching.